Okay, Joe, can you see my board?
Yeah.
Okay, what we have essentially discussed in our previous class was conic sections over the real numbers, and we have seen that the conic sections, all conic sections are essentially, as you said, quadratic equation in two variables. That's why they are known as quadratic curves. Okay, we are not quadratic equation, the solutions of a quadratic equation in two variables. Okay. And such a quadratic equation can be written as ax squared plus bxy plus cy squared plus dx plus ey plus h equals 0.
Okay.
Okay, and the values of x and y for which the equation is equal to 0, meaning the term here, the polynomial vanishes, is the solutions, are the solutions.
Okay.
Okay, so we try to solve it by converting that equation into essentially an equation in x,
one
variable. But it looks like one variable, but it is actually equation in two variable. It is a rearranged form.
Yes.
Okay, since x and y are real numbers, we want this term. This is very important term. This discriminant as should be either it should be equal to 0
or greater than 0.
Exactly. Okay, that's the condition, and that condition is actually the turning point here, and that condition results in various kinds of sub conditions that will result that we will see today, that results in various different kinds of conic sections. And I have said that that kind of that is actually a purely algebraic classification of the conic section.
Yes.
Okay, in our school days we have studied that conic sections can be classified based on a geometric number called eccentricity.
Yes.
But today we will see that we can classify them purely in purely algebraic terms. It's very fascinating, and this classification actually reveals so much structure. Okay.
Okay.
This is a prime example of how algebra can easily overpower geometry, because algebra reveals the structure underpinning
different geometries.
This different kinds of. Here we are studying conic sections. It is actually a fact for almost all branches of mathematics. Algebra is reveals so much structure. Okay, we have the condition is b squared minus 4ac should be greater than or equal to 0, and this discriminant we converted it into a quadratic equation y.
Yeah.
Quadratic inequality in quadratic inequality. Okay, and we have for the first case as a case 1, we have assumed that this coefficient of this the leading term y square is equal to 0. Because it can be 0, it can be less than 0, it can be greater than 0, it can be 1, or it can have any values. Because essentially we haven't placed any constraints on the coefficients. This is a general quadratic equation. A, B, C, D can have any real values. Okay. Okay. As a case, first case, we have assumed that let it be 0. Okay, and we have seen that if that is the condition, the corresponding conic section will be a parabola.
Okay.
And that we have proved it purely algebraically. I am so proud of this proof, because there is no logic involved, there is no reasoning involved, pure polynomial algebra.
Okay.
The proof is so simple and algebraically. I'm not praising myself, but this is I am so much fascinated by this kind of simple algebraic proof, because there is no prerequisite to study to understand this proof. Just manipulate symbols.
Yeah, just logic.
No, there is no logic
logical
involved.
step. No, just mathematical logic. Just
writing
out the.
Okay, just manipulations, 8th grade mathematics. Okay, anyway, let's continue. Let's look at case 2. But before that, let's look at this sentence in detail. I have written here that in this case the conic will be a parabola. Okay. Yeah. The question is, where is the parabola formed? Where is it?
It's in the XY plane.
Yes, exactly. It's in the XY plane. This is a delta y delta XY plane.
Yeah.
Okay.
Okay.
Okay. Whenever the delta x, which is the discriminant, greater than or equal to 0, we get a conic section, meaning we get a curve in the XY plane, which we
Yes.
haven't drawn here actually.
Yeah.
That's what we will going to study today. Okay, what is happening in XY plane, meaning the plane in which this polynomial is being plotted.
Okay.
This is a plot of the discriminant and y, meaning this is a plot of this inequality. Okay, this is the discriminant, and this is the variable y. This plot actually represents this inequality, not the plot we needed. Okay, we need this.
Yeah.
Okay, that's what we are going to study first. What is the plot look like? Okay, what will
be the plot
of ax squared plus bxy plus cy squared plus dx plus ey plus h looks like?
Okay.
What look like? What will be the plot of this look like? Okay. For that, I am naming this. Let me name this as a polynomial in x and y.
Okay. So you will plot it in an internet.
Okay. Simplicity, let it be f of xy.
Okay.
This is
Function
easy
of xy.
ax squared plus bxy plus cy squared plus
dx plus ey plus h is equal to 0.
Okay.
No, not like it's a function. Okay.
Function. Okay. But we are actually interested in equal to 0. Meaning we are interested in the values of y and x and y for which this equal to 0.
Yeah. So you will plot it in a 3-dimensional graph, I think.
Exactly. We will plot it in a 3D space of x, y, and f of xy.
Okay.
Okay, this is x, this is y, and this is z equals
f of xy.
Okay. Since x comma y are reals, meaning natural rational number. Okay. We are real. We can essentially plug in the values what we want. Okay, and find the value of this polynomial. Okay, so this will look like a manifold here. Okay, something like that. Just an arbitrary. It can be anything. Okay. For this to be an equation, meaning when this is equals 0, there is no equality involved. This is just a polynomial.
Yeah.
Okay, but we are interested in an equation. This is when for what values of x and y will this be equal to 0?
Yeah.
0, meaning we want to find the values of x and y for which this manifold crosses the xy plane.
Yeah, so you are essentially taking the projection of this f of xy in xy plane. Not projection
is not a projection, but
yeah, where this manifold intersects the x and y plane.
xy plane.
Okay.
Okay. When this equal to 0, meaning this should actually touch here because this is the point of c equal to 0.
Yeah.
It may actually touch and make I don't know, some cross this and come back. anything
Yeah.
can happen. Depends on that depends on the values of a, b, c,
A,
d,
B, C,
and
yeah.
okay. Okay, this may be like an ellipse or a hyperbola. It can be anything.
Okay.
Okay, this is x and this is y, and this the points of intersection is actually called conic section.
Section, yeah.
This is what happens when we plot the polynomial in the x, y, and c space. C means z space.
Okay.
Okay, this what will be the plot of look like this. It will look like this. Okay. Okay, so Joe, I will show you this in using a graph plotter.
Okay.
Okay, this is a very interesting. As I said earlier, when I when I recognized that this is actually what's happening, it was like a light bulb just because we haven't thought about conic sections this way. Algebraically, this is what happens. Algebraically, we have a polynomial equation, very polynomial, and that polynomial, when it is equal to 0, meaning that the manifold of that polynomial should cut through the x-axis, xy plane, and the points of where that plot touches the xy plane is the conic section.
Okay.
This is I don't know if your mind is being blown or not. When I first learned about this, I was okay. Let me show a graph plotter. Switch. Okay. Can you see, Joe?
No, I think it's being loaded. Yeah, it's come. Yeah.
This is a very simple, very easy to use online graph plotter. This is not sophisticated as MATLAB or Maple or GeoGebra. Okay, this way, but I like it because this is very simple. I use it often. Okay, this they have okay, they have many global math art contests. Many they are the Desmos Studio is being sponsored by
Cambridge.
Cambridge and other publications. Okay, let's use their new 3D graph plotter. Let me put it in perspective and reverse contrast. Okay, we can just plug in. Let's put an arbitrary
Value.
value.
Quadratic.
Okay. I have actually typed an value here. Let me
Okay.
copy and paste it. Okay. This is just a polynomial in two variable. Quadratic polynomial in two variable, meaning f of xy. This is just an f of xy.
Yeah.
This is not an equation. This is just an f of x.
That's why it forms a surface.
Okay, this is 14x squared minus 7x minus 4x xy plus 11y. Come on.
Yes, 11y square minus 4x 44x minus 58y plus 71. Okay, when you put it form the surface here.
Yeah, because this is x-axis, this is y-axis. This is similar to the graph I have drawn.
Okay.
And you will when you plot it for various values of x and y, you get different various z values. Okay. And that will result in a 3D manifold.
Okay.
Okay, and we want this polynomial to be 0. So I'm equating it to 0, meaning we want to find the meaning.
We want to find all the points.
Z becomes
0.
Meaning we will only get a 2D value for which this is 0. Okay, let me
collection of points in that plane.
plane. Okay, that's it.
Yeah, it did.
Okay, this is
an ellipse.
Exactly.
Almost like a circle. It's almost like a circle. Yeah.
This is what happens. Okay. If we change the values, I will change into say plus 34. What is?
It's a hyperbola.
Hyperbola because without 0, we equal to getting putting it equal, making it equal to 0. Let's first look at the manifold formed. Okay, the polynomial.
Okay.
This is what it will look like.
Okay.
This joins here. Yes. Okay.
Okay.
This passes through. This passes through the xy plane at the points where this is equal to 0, which actually results in a hyperbola.
Okay.
Similarly, you can plug in various kinds of values for these A, B, C, D, E, and A, B, C, D, E, and H.
Okay.
And you will get various kinds of ellipse or hyperbola or parabola. Okay. Okay, Joe?
Yes.
Okay, this is actually what's happening behind the scene. Okay, when we are saying considering conic sections, we are only dealing with this xy plane, but this is actually part of a large structure.
Yes.
Okay, this is a very interesting idea. Meaning there is lot to explore here. Okay. Okay, let me show you my board. Okay. Can you see the board, Joe?
Yes.
Okay. Now let's return to our discussion. Because to continue our discussion, this is very important. This idea is very important. Now, let's look at case 2.
Okay.
Joe, I will promise you today, I will blow your mind. Okay. There are very interesting ideas in today's discussion. Okay. As in case 2, in case 1, what we have assumed was
the discriminant b square minus 4ac equal to
the
0.
leading term of the discriminant.
Yeah.
Not discriminant of the discriminant. In the previous video, I joked said discriminant of it. No, it's not. It's jokes aside. This is the leading term of the discriminant.
Discriminant, yeah.
Okay, discriminant of what? Discriminant of our conic, the
polynomial.
Okay. And this b squared minus 4ac is the leading term of the discriminant.
Yes.
It can be 0, greater than 0, or less than 0, whatever. First case, as case 1, we have assumed this is equal to 0. As case 2, I am assuming this is, I don't know, less than 0. Okay. As case 2, let's assume as case 2.
Okay.
Case case 2, b squared minus 4ac is less than 0.
Okay.
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 What is our delta x of y? What is our delta x of y? B squared 4ac y squared, b squared minus 4ac times y squared plus, I think it's 2bd minus 4ae.
Yeah.
I'm not sure. bd minus 4ae times y times 2bd minus 4ae times y plus, I think it's d squared 4h. Correct, Joe?
Let me just check. B square minus 4ae or 4ac times y square into 2bd, something like that, isn't it? 2bd.
2bd minus 4ae.
Let me just check. Where is it? 2bd minus 4ae. Yeah, 2bd minus 4ae times y, isn't it?
Yes.
Y plus d square minus 4h.
Discriminant for okay. This discriminant should be greater than or equal to 0. That's the condition.
Yeah.
Okay. let's this is a quadratic equation in y with
Yes.
quadratic inequality in y. Okay.
Yes.
Okay, this should be greater than or equal to 0.
Yes.
Okay, first just recollect what does the graph of a quadratic equation looks like. Let's just
it's a parabola.
okay, exactly. Let's a slight detour, here. Okay. Okay, consider a general I don't know, quadratic equation ax squared plus. Okay, slight detour. Quadratic equation. Okay, just take a general quadratic equation ax squared plus b x plus c equals
0.
Okay, equals 0. Okay, correct. Okay, what will its graph look like? If a equals 0, if a equals 0,
then it will be a straight line.
So that's actually the case one. A equals 0. This is
straight line.
Let's not make it an equation. Let's just make it a polynomial. Okay, function.
Okay.
If a equals 0, this will be straight line.
Straight line. Yeah.
We have seen this in the case of parabola. When a is less than 0, when a is greater than 0, what will it look like?
It will be a parabola.
Parabola facing
upwards.
Correct. When a is positive, meaning the coefficient of the leading term is positive, we will get a parabola facing upwards. But it can happen in 3 different ways. That's the idea.
Okay.
Parabola, it can be like this. It can be like Joe, just give me a second because I want it to the way our discussion is going. Okay. It can be, it doesn't matter, just it can be like this, it can be like this, it can be like this.
Yes.
Okay.
Okay.
This is x, this is f of x, meaning this polynomial. Okay.
It can also be completely below the x-axis, isn't it?
No, because the parabola extends
no.
infinity.
Okay. Oh yeah. Okay.
Okay.
All right.
This extends up to
to
whatever
infinity.
point we can.
Okay.
Infinity meaning whatever point we can plug in.
Plug it
to our plotting device. Okay. Okay. What is the condition for this? When will this happen? Okay. This happens when. Okay. First, let's solve this using usual. What is the solution? What will be its solution? X equals
b square minus b plus or minus b square minus 4ac divided by 2a.
2a. Okay. This happens when b square minus 4. There is no zeros.
Yeah.
Meaning the discriminant is a.
Discriminant should be a complex number.
Discriminant should be negative number.
Negative
so that
number.
square root will be okay, because we are dealing with the real numbers here. Okay, we don't want. But we will study conic sections in complex domain. But today I went. Our current discussion is only
on real numbers.
Restricted to real numbers. Okay. Okay. This happened. The case one. This. I am using the word case so many times. Let's just write 1, 2, 3. Okay.
Yeah.
1, 2, 3. 1 is b squared minus 4ac less than 0.
Okay.
So that the discriminant becomes negative, and for no real x will the function
touch
will
the
this equation be satisfied.
Yeah.
Meaning for no real x will the function touch the x-axis, or f of x becomes 0.
0. Yeah.
This happens when
there
b
are
squared
minus 4ac equal to 0.
0 exactly. This happens when b squared minus 4ac equals 0. Then what will our solution look like? X equals minus b by
2a.
2a. Exactly. This point is minus b by 2a. This point x, the value of x will be minus b by 2a. This happens. When will this happen, Joe?
It will be greater than 0. B square minus 4s. There will be two roots.
Exactly. B square minus 4ac greater than 0. Then x becomes minus b by 2a plus
b square minus 4ac by 2a
plus b squared minus 4ac by 2a, and or it can, or mean it can have any 2a.
Yeah.
Or x equals minus b by 2a minus square root of b squared minus
4ac divided by 2a.
Okay, these are the two values of x.
Okay.
These are the two values of x for which this equation, this polynomial equals 0. Okay, meaning this polynomial f of x touches the x-axis, meaning it will be, the y-axis becomes 0.
Okay.
Okay.
All right.
So let's go back to our discussion. In our case, the quadratic equation is this. Okay, and we have assumed that b square minus 4ac, I mean the a here is b square minus 4ac.
Yeah.
Okay.
It is less than 0. Okay.
We have assumed that this is less than 0.
Yes.
So okay, we have only talked about the greater than 0 situation. We have to also talk about the less than situation. What happens when f in the equation ax squared plus bx plus c equals 0? What happens when a is less than 0?
When a is less than 0, you will have a parabola which is open downwards.
Correct, exactly. We will have a parabola open downwards. Okay. Okay, I want this to be correct with the same pattern with our discussion. Okay. It can be this way. It can just touch one of the value, one at a single point, and it can be like this.
Yeah.
Okay.
Okay.
This happens when
there is no real solution to the problem.
No. This is actually a bit more complicated, because let me look at it. Let's actually
discuss.
No. Let me think. Actually, x square minus b square minus 4 is equal to 0. Joe, actually, I think you're correct. Okay, this happens when b square minus 4ac is negative, because for no real numbers can the equation become 0. This happens. Let me name this. Yeah, you are correct. You're correct. It's 1, 2, and 3.
Just
one
like
happens. Yes, one happens when I got confused with our quadratic equation. Okay. This happens when b squared minus 4ac. B squared minus 4ac. You have to understand this is discriminant here, not our b square minus 4ac. That's what I got confused with. Okay. Okay. Here b square minus 4ac. B squared minus 4ac. Where b square minus 4 is the discriminant. It is a discriminant here.
Okay. I understood that.
X equals minus b plus or minus square root of b squared minus 4ac by 2a. B square minus 4ac is this happens when this is less than 0. 2. The case 2 happens when this is
greater than equal to 0.
0. This happens
when it is greater than 0.
Okay. This is what our condition. This is what our quadratic. This is we know this from our school period. Okay. Let's come back to our situation. In our case, quadratic polynomial is this.
Yes.
Okay. Let me rewrite this here. Delta x of y, meaning the f of x. Here looks like b squared minus 4ac times y squared plus 2bd minus 4ae times y plus d squared minus 4ah should be greater than or equal to 0. And we have assumed that this
b square less than 0.
Exactly, b square minus 4 is less than 0. So this condition will happen. These three graphs can happen. Okay. In this case, any one of the following graphs can happen. Okay, that depends on the coefficient values. That depends on this condition. So let me write. Okay. This is delta x of y. This is our f of x, and this is for instead of x we have y here. Okay. And it can be like this. It can be like this, or it can touch on a single point. Okay, or it can cross. Okay, Joe?
Yes, I'm drawing it here also.
Okay, Joe, draw.
Okay.
In the case 1, delta x to be greater than or equal to 0.
Yes.
Okay. In this case, will it satisfy this inequality? If this is the case, will it satisfy this inequality? Meaning that will delta xy, will it be either we want it should be either equal to 0 or greater than 0. In this case, will it satisfy that condition?
I cannot say about that. Case 1.
Why not?
Okay, it may depend upon the values of.
What is the condition, Joe? This is the condition is delta xy should be greater than or equal to 0. This is the delta xy.
Oh yeah, it should. It will not work. It will always be less.
Yes. In this case, for no values of y will be we will get the discriminant greater than 0.
Yeah.
here for no y, no values of y, delta xy becomes greater than or equal to 0. In that case, no conic section will be formed in the xy plane.
Okay.
In the xy plane.
Okay.
Okay, that's the idea.
Okay.
In this case, no conic.
You can just write no conic section formed.
No conic section. Okay, let's because we are giving our study note freely available online. Okay, so if someone wants to download and read it, in this case, no conic section will be formed where in the xy plane. It's very important, in the xy plane, because conic sections are formed in the xy plane.
Yes.
This is the plot of y delta xy, and we are checking whether checking the values of y for which delta xy is greater than 0, so that a conic section can form there.
Yes.
This is algebraic geometry within algebraic geometry.
Yes.
Okay, we are finding the values region where regions of y where the delta xy becomes greater than or equal to 0, so that a conic section can form in the xy plane.
Yes.
Okay.
Okay.
Here no values, for no values of y can the 0. Okay, so this inequality becomes violated. So what will happen? So so that this delta xy, meaning this is delta xy. Okay, this is our main condition, greater than 0. For no values of y will this become greater than 0, so that no x will result, I mean, in the xy plane.
Yes.
This is the plot, xy plane. This plot is the xy plane. Okay, as we have seen here. Okay, what will happen in this condition? Let's assume there is for a single value of y.
There is a conic section.
Y naught. Okay, for a single value of y, delta xy touches the y-axis, meaning delta xy becomes equal to 0.
Yeah.
Only one y is there to make delta x of y equal to 0. Okay.
Okay.
Okay, only one y equal to delta xy equals 0. It's not greater than 0. Till no, it's not greater than 0. It is equal to 0. Then what will happen if delta xy equal, meaning in this equation this term vanishes.
Okay.
Polynomial, main polynomial, our main thing, x equals minus b plus or minus delta x of y. This is our by 2a. This is our solution, correct?
Yes.
Here this becomes 0. This becomes 0. Therefore, we get x equals minus b by 2a. This a is small letter a. We know that.
Okay.
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 So what is b? B is, if you remember, b is minus b is just a by plus d.
Okay.
By plus d. Okay.
Okay.
This happens when y equals y naught, correct?
Yes. Yes.
I have named it y naught. So this happens when x equals minus by naught plus d. I have substituted. Okay. Okay. So we will get by naught plus d as x coordinate and y coordinate as y naught.
1 second, let me just, so this will be equal to minus b divided by 2a. Delta xy should be equal, and so y will be equal to 0. Yeah, so our b was
2x.
capital B. Yeah, our
let me write it
b
clearly.
was, yeah,
Minus b y naught plus d by 2a. This is the value of x when y equals y naught.
Plus d divided by 2a. A is
A in our
simply
polynomial.
Yeah, yeah, a is a divided by a. Yes.
Okay.
So this corresponds to a single point.
This single point. So
Yes.
our conic section is a single point.
Okay.
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 Here the conic section will be a single point, meaning the manifold just touches in the xy plane.
Okay.
Okay. Okay.
Okay.
Okay. Now we will move on to the next condition. That is very important condition.
Yeah.
What will, if this kind of graph is if this is the graph for delta x of y.
For a range of y values, we'll have
exactly for this. This is the range of y values for which
y1 to y2.
I mean, let me. This actually requires a detailed study. I'm thinking whether I should write it
we can.
here. Okay, okay, I will write it here.
Okay.
Okay, let me name these 2 points as
y1 and y2.
no. Okay, Joe, what will can you guess what will these points be? To find that, you have to just make it equal to 0. This equation equal to 0.
Yeah.
It will be very cumbersome, but if we can make it equal to 0 and find using the quadratic formula minus b plus or minus, it will be a giant formula.
Yes.
Okay, you can find 2 roots.
Yes.
And those 2 roots will be our required these 2 points. I'm naming it alpha and beta.
Okay.
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 Okay. I'm not going to solve it using that heavy algebra, but we have to solve it. In the next class, we have to solve it. There is a very important case happening. Okay, but today we will just Joe, I don't know, there is okay, some vehicle just passed by and there was a lot of noise. Okay. Okay, alpha and beta, let these 2 be the roots, 2 roots. To find the, you can Joe, if you want to find the roots, just make it equal to 0. This equation equals 0, delta xy equals 0, and solve it. It will be a very cumbersome result. But today we will not be getting into that result. But in the next class we have to, because there is a very interesting kind of conic section. For that we have to solve this. But today just let's name it a alpha and beta.
Okay.
Okay. And I'll write it here. If this is the condition, very important. If this is the case, the corresponding conic will be an ellipse.
Okay.
Very important. I'll give you the proof. But just think about it. If this is the case.
Okay.
Okay. Let me give me a proof. This proof, I'm not so that proud about this proof. I'm like a parabola. It was very elegant. but this is okay. Just let me give you the proof. Okay, for that, I'm if this is alpha and this is beta, what will be its midpoint?
Alpha plus beta divided by 2.
Okay. Okay.
Okay.
Okay, Joe. Let me name that point K.
Okay.
Okay. Okay, I will write since we are writing the proof here. I will write it. I'll draw it once again. Oh, what just happened? Okay. Okay. Let it be alpha. Let this point be beta, and the midpoint be alpha plus beta over 2, and let me name it as K.
Okay.
Okay. So this distance, meaning this distance, I'm going to name it as B.
Okay, 1 minute. Let me just check. Understand that.
This distance I'm going to let it be B. Okay.
Midpoint is K. The which distance?
The center to those 2 points.
Okay. Yeah.
Okay.
Okay.
So that K equals
Alpha plus beta. Alpha plus B.
B, and K plus B equals beta.
Okay.
From this, what will be the alpha here? Alpha will be alpha equals K minus beta. K minus B.
Yeah.
Alpha will be K minus B. And beta will be
K plus B.
Beta will be K plus B. Okay.
Okay.
And the Y value is actually in between alpha and beta.
Yes.
Okay. Those are the values of Y for which the delta XY will becomes greater than 0 or equal to 0, meaning we have Y element of Y belongs to closed interval
Closed interval. Yeah.
Right.
Yes.
Or I mean, if you can also write it alpha less than or equal to Y less. Okay.
Yeah.
Okay, Joe. Understood?
Yes. Yes.
Okay, what is alpha? We have found the values of alpha and beta here. What is alpha?
K minus B.
Okay, so K minus B less than or equal to Y less than or equal to
K plus B.
X, K plus B. Okay.
Okay.
These are two inequalities. Let me separate it. Let's do it separately. We have K minus B less than or equal to Y and Y less than or equal to K plus B.
Yes.
Okay.
Okay.
From this we can find in the from the equality I have written in the left side, we can find minus B is less than or equal to Y minus K.
Yes.
Similarly, we can also find Y minus K from the right inequality. What will be the right Y minus K?
Okay, right inequality Y minus K will be less than or equal to plus B.
Plus B. Okay, correct. Okay, now we have two inequalities with Y minus K, so we can combine this, correct?
Yes.
What will be the inequality, Joe?
Minus B less than or equal to Y minus K less than or equal to b.
Less than or equal to b. Okay.
Okay.
Meaning we can write y minus k will be less than or equal to absolute value of y minus k will be less than or equal to absolute value of b.
B. Yeah.
Okay, because it
Yeah.
lies in minus b and plus. So even if it is negative or positive, when we take the absolute value, it will always be less than the absolute value of b. Okay.
Okay.
Okay. To explain, if someone has
Yeah,
doubt,
I
I will
understood.
explain this. Okay.
I understood.
Okay. If it is minus b, if this is minus b and if this is b, the y minus k lies here.
Yes.
Like lies somewhere around here. Let it.
Yeah.
Okay.
Yeah.
Let this be 0. Minus b at the midpoint there is 0.
Okay.
Okay.
Okay, I understood.
Okay, if let y minus k be here. So if we take the absolute value, it will always will be less than the absolute value. Okay. So okay, now what? Okay. Okay, now if we square the inequality, what will happen? What we will get?
Square
Y
the
minus
inequality.
k.
The whole square will be less than or equal to b squared.
Okay.
Okay.
This is true because the absolute values are always positive.
Yeah.
Okay, for like if 2 is less than 3,
Yeah.
2 square will always be less than 3
3.
square.
3 square. Yeah.
Okay, this is less than, we can always square it. It will never violate the inequality. Since b is a positive number, since b square is a positive number, since
b square and y
b square
minus
is greater than 0, we can divide throughout the inequality, right?
yes.
It will not alter the sign because it is b square is a positive number.
Okay.
We can divide. So we will get what? Y minus k.
B square will always be greater than or equal to 1. Less than or equal to 1.
Over b squared will be b squared minus b squared by b squared, which is b squared by b squared, b squared by b squared, which will result in 1. Okay.
Okay.
Now let me check. Joe, wait. Okay. Now I will move this term to the RHS.
Which term?
This term y minus k whole squared over b squared.
Okay. So 1 over b squared. Okay.
This is getting to, this is taking Canada. Okay, there is space here. Okay. Okay, so we will get to 0 will be greater than, less than or equal to 1 minus y minus k whole squared over b squared. Okay.
Okay. Yeah.
Meaning this term, this entire term is greater than or equal to 0, right?
Yeah.
So we can take its square root.
Okay.
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 So since this term, which term? This term.
1 minus y minus
is
k.
positive, which is non-negative, is
Okay.
non-negative,
Greater than 0.
We can
take square root.
take its square root. Okay, so we will get square root of plus or minus. Just take square root 1 minus y minus k whole squared over b squared. Let me name that square root as x minus h by a. I will explain it. Just write it. Okay.
Okay.
Okay. You can. I'll write it here. If someone downloads the note, I am. Let us name the square root. Square root plus or minus x minus h over a.
Okay, is this
Therefore,
related to our h in the equation?
No.
Okay, so it's
This is just h is an arbitrary number.
okay.
Okay, I am putting those h and b and a are arbitrary number. I have just gave because I'm plugging in these numbers so that I can get a result.
Okay.
You will see. Okay, so we will get plus or minus x minus h over a is the square root of 1 minus y minus k whole squared over b squared.
Yes.
Okay.
Okay.
Okay. You can also put just
Square.
x. You can also put just x.
Okay.
Okay. But I want to arrive at a certain form.
Yeah, I got it. So if you square this one,
you what will the result? Squaring,
you will get the equation for the ellipse.
exactly, x minus h the whole squared over a squared equals 1 minus y minus k whole squared over b squared. This becomes x minus h the whole squared over a squared plus
y minus
y
k
minus k the whole squared over b squared equals 1. This is the equation of an ellipse
centered at hk.
Exactly, centered at h comma k. Okay, if I just give this number an x, okay, it will be an x centered at the origin or I don't know. Okay, I just put these values so that I can get a nice result. Okay, even if you put just x, it's okay. It's just still an ellipse. Okay. So okay, and then the meaning the shape of the curve formed here actually determines what kind of conic section are we getting in the xy plane.
Okay.
That's a big takeaway here.
Okay. So if it's an upward facing curve, I think it will give you a
that we will discuss in the next
class.
class, but there is a big surprise also coming because we will be looking at a different type of conic section which is not an ellipse, not a hyperbola, and not a parabola.
Wow.
Okay.